We are going to, of course, I started this semester with okay. How do you like that? I know all my videos start with okay, but here we go. So with this semester, like we said before, or like I've said in your email, like I've said in your live stream if you were there, we are going to be doing physics and physics with a workbook. So the workbook is because this becomes more of a math class. I wanted something to where it would be all in one place for you. The workbook comes in two parts. So part one is going to go until March, and part two finishes out the semester. When we talk about all of this stuff, it'll kind of build upon each other. So I'll teach you different methods to find these different answers. I will teach you different methods to find different stuff. I know I have a video out for dimensional analysis already for you. This is, I think we're going to stick with the Edpuzzle for you guys. Uh, we will do the Edpuzzle. You'll still have notes if you'd like it, so that way you can go back and look at it for your quizzes. Because all your quizzes will be open note, like last semester, and make sure that you use these notes to the best of your ability, so that way it'll help you out. Now, that being said, we're going to start with measurements, so that way we know what we're getting into. Dimensional analysis talks about your American system to metric and back and forth. Metric system is what we're going to use in the system of science that we use. So the metric system is a measurement-based system based on our decimal system, so our powers of 10. So powers of 10 is also called scientific notation. This is used by scientists everywhere. In the medical field, everybody uses the metric system. In other places in the US, we have been more adept to not do it. Now, this is because of different reasons. We've had our own system for so long, it got switched up, things like that. I mean, if you look at the metric system, it is much better than anything else. Now, it has been around since the French Revolution, so around the turn of the 19th century, so the 1800s. So that's technically 1779 was the first date it was invented. But it has been something that has been neglected by the United States for many years. But as you can see, since we are in a national or in a global world and a global economy, global back and forth in trade, the metric system is important to us. Uh, we do have some differences in our opinions with as Americans, but I'm going to show you why the metric system is so much better. When we look at the metric prefixes mean different things. So kilo means 1,000. If you look at 10 to the third power, all of these mean is that you are multiplying by 10 this many times. So if you look at your positives, if I look at kilo means 1,000, so 10 times 10 times 10 is 10 to the third. That means that we are looking at 1,000 because 10 times 10 is 100, 10 times 100 is 1,000. Hecto is 100 because 10 times 10 is 100. Deca is just 110, and 10 to the 0 is just 1. Anything to the 0 power is just going to be 1. So our base units are going to be this 1. So whether that be meters, liters, or grams. Deci, centi, milli are all in our decimals, so that we will have decimals of that from our 1 unit. So there are 1,000 millimeters in 1 meter, things like that. The other way to think about this, so you can do the multiplication way, or you can do a decimal way to where you look at the ladder and you just move the decimal however many places you need to move to the next place. We'll go over that in a minute. But meters measure distance and length and width and height, things like that. So it is a one-dimensional measurement. So a millimeter is about the thickness of a dime. If you look at a meter stick, there are 1,000 little lines for millimeters because there are 1,000 millimeters in 1 meter. A centimeter is about the width of your fingernail. So when you look at your fingernail, that is going to be the width of a centimeter. A meter is about a doorway, or think about it as so a 6'1" person is about 2 meters, about 1.9 meters. So it's about half the height of a person, maybe the height of a toddler. A kilometer, of course, is 1.6 kilometers in a mile. So a 5K is going to be less than 5 miles. It's going to be about 3.2 miles. Think about if you're a runner, kilometers is how everybody else measures it. If we run distance, you're talking more about that. If you go to other places, they measure speed in kilometers per hour. That'll be what you use when we go over speed in our system. Now, grams are our base unit for mass. Grams are very small. Think about how small a grain of salt is, and that is a milligram. So 1 gram of salt, 1 grain of salt is a milligram. That's how tiny we can weigh it down to. Now, a gram weighs about as much as a paperclip. So when you're measuring your weight, or you're measuring something that is of great weight, you will be using kilograms because that matches up better. So a kilogram is about 2 pounds, meaning you're looking at probably 1.9 pounds. So an average human being weighs about 155, 165, and that's about 70 kilograms. So we're looking at about half. So thereabouts. So if you were to measure yourself in kilograms, you would weigh less, but not really. It's just a different measurement. Liters are a measurement of capacity. Capacity is also known as volume. Liquids are what we look at with liters, because the only way we can measure liquids volume is to put it into something. Liters measure volume, which is length times width times height. So think of it as a 3-dimensional measurement. A 2-dimensional measurement is going to be something like area, because if you take length times width, you've heard of that. That's just showing you the floor space of the room that you're in right now. Now, if you wanted to see how much gas or how much air is being brought up in the room, you do the height of the room as well. So you take the length, the width, and the height of the room, and you see how much actual space is in that room. You think of space as places to put furniture, but really it's just however much space there is to move around in it, both vertically, horizontally, and with depth. So 1 milliliter is about a drop of a liquid. 1 liter, of course, is a half of a 2 liter. And a kiloliter, so since kilo is 1,000, and we look at 2 liters, 2 divided by 1,000, or 1,000 divided by 2 is going to be 500. If that makes sense. All right. So given on this, what do you think that you would measure a bike in? It's up to you. I'm gonna let you choose that on the Edpuzzle. What would you measure the mass of a penny? So remember, mass, not length, and not width, not volume, but mass. What would you measure the water in an aquarium? So the volume of the aquarium, and that could just really depend on the size of the aquarium. And what would you measure the mass of a feather in based on what you're given down here? So when we change metric units, to change from one to another, the metric system, you apply or divide or multiply by a negative integer of a power of 10. Integers these right here. So to change from a larger unit to a smaller unit, you need to multiply by a positive integer. So that means for every 1 kilometer, there's going to be 1,000 meters. For every 1 meter, there's going to be 1,000 millimeters. For every 1 centimeter, there's going to be 10 millimeters. And so on and so forth. But if we are going to want to do that, all we have to do is say we're going from kilometers to meters. We just take our decimal, wherever it is, and move it to the right 1, 2, 3. And that will give us our same answer. So you can either multiply or you can move the decimal point to the right. Both of these are technically multiplications because the metric system is based on our decimal system. Does that make sense? If it doesn't, please email. So if we're going from a smaller unit to a larger unit, you must multiply by a negative power of 10. So if I'm going from a smaller unit to a larger unit, so millimeters to centimeters, I'm going to multiply by 10 to the negative 1. So basically, this is just multiplying by 0.1. So any negative means that you're moving the decimal from the right to the left. So in this case, if we're going from centimeter to millimeter, we're going to go 1, 2. So we're moving it from the right to the left. That is the two ways of doing it. You can either multiply, which I showed you in one of the videos, or you can move the decimal. Either is fine. So please finish page 4 of your workbook. Have that turned in as assignment 1.1. And your dimensional analysis is going to be assignment 1.2, and that will be pages 5 through halfway through 9. So once it says end of assignment in that page, then that's what you'll do. If you do not have a workbook, you'll just use what you're given on Google Classroom. Please turn that in by Sunday. Remember, all due dates are Sunday, and that is all for today. If you have any questions, please ask, and we will be good to go. All right? Let me know.